On February 10, 2025, Ukraine announced a strategic enhancement of its military capabilities by deploying advanced laser mobile firepower units to counter the persistent threat posed by Russian Shahed drones. This initiative was confirmed by Colonel Vadym Sukharevskyi, the commander of Ukraine's Armed Forces Unmanned Systems Forces, who highlighted the growing importance of unmanned capabilities in the ongoing conflict with Russia. Sukharevskyi emphasized that laser weapon systems have demonstrated promising results in tests showcasing their ability to penetrate aircraft metal and engage targets at altitudes exceeding 2 kilometers. The move to incorporate laser weapons into Ukraine's military strategy comes as a response to the significant challenges posed by Iranian-supplied drones used by Russia. The mobile fire groups, traditionally reliant on machine guns and thermal imaging systems for counter-drone operations, are set to receive these innovative laser systems. This marks a notable shift in the approach to aerial threat neutralization as Ukraine aims to integrate advanced technology to improve its defensive capabilities. Sukharevskyi stated that the development of laser weaponry is a key priority for the Ukrainian military aimed at transforming the battlefield dynamics. He noted that the Trizub laser weapon has already undergone testing and has been confirmed for operational use against Russian targets, demonstrating its effectiveness in practical scenarios. The incorporation of laser systems into the mobile fire groups signifies a strategic evolution in Ukraine's approach to air defense, complementing existing anti-air capabilities. Ukrainian President Volodymyr Zelenskyy echoed the sentiments of military leaders, emphasizing the advancements made in domestic counter-drone technologies. In a recent interview, he expressed optimism regarding ongoing projects aimed at enhancing drone defense, stating that they are nearing consistent and effective results. Zelenskyy highlighted the critical importance of refining these systems to ensure they achieve the desired outcomes on a broader scale. Despite the optimism surrounding laser technology, military analysts have raised concerns regarding the operational limitations of such systems. Experts point out that while laser weapons could be effective against drones, they may face challenges when dealing with fast-moving aerial threats. Operational requirements such as energy supply and integration with existing air defense frameworks remain critical factors in determining the practical deployment of laser systems. Moreover, environmental conditions, including adverse weather and smoke, could significantly impact the performance of these directed energy weapons. The backdrop of this development is the ongoing conflict between Ukraine and Russia, which has seen a continuous evolution of military tactics and technologies. As Ukraine actively seeks innovative solutions to counter Russian aerial threats, the introduction of laser technology aligns with a broader global trend where nations including the United States, United Kingdom, China, and Israel are investing in laser weaponry as a cost-effective means to address aerial challenges. In summary, Ukraine's deployment of mobile laser firepower units represents a strategic and innovative response to the multifaceted challenges posed by Russian Shahed drones. While there is optimism about the potential effectiveness of these systems, ongoing testing and integration efforts will be crucial in determining their practical impact in the field. The move underscores Ukraine's commitment to enhancing its military capabilities in the face of evolving threats, with a focus on leveraging advanced technology to safeguard its sovereignty and territorial integrity. Ukraine is set to deploy advanced laser mobile firepower units as a strategic response to the ongoing threat posed by Russian Shahed drones, a situation underscored by Colonel Vadym Sukharevskyi, the commander of Ukraine's Armed Forces Unmanned Systems Forces. This initiative emphasizes the significance of unmanned capabilities in the current conflict, with Sukharevskyi highlighting that laser weapon systems have demonstrated promising results, including their ability to penetrate aircraft metal and engage targets at altitudes exceeding 2 kilometers. The deployment of these laser systems marks a significant shift in Ukraine's counter-drone operations, moving away from the traditional reliance on machine guns and thermal imaging. The Trizub laser weapon, which has already undergone testing and confirmed operational capacity against Russian targets, represents a critical advancement in Ukraine's military capabilities. The mobile fire units tasked with maintaining 24/7 readiness during air raid alerts will soon be equipped with these laser systems, enhancing their ability to engage various airborne threats, including loitering munitions and reconnaissance drones. Ukrainian President Volodymyr Zelenskyy has also acknowledged the advancements in domestic counter-drone technologies. He expressed optimism regarding ongoing projects aimed at enhancing drone defense, emphasizing the importance of refining these systems to achieve consistent effectiveness. Zelensky's comments underline the priority of counter-drone initiatives in Ukraine's military strategy. Despite the optimism surrounding the deployment of laser weapons, military analysts express concerns regarding their operational limitations. While laser systems are viewed as potentially effective against drones, experts caution that they may struggle with fast-moving aerial threats. There are specific requirements regarding energy provision and integration within existing air defense frameworks that could pose challenges. Additionally, environmental conditions such as adverse weather or smoke could hinder the performance of laser systems, raising questions about their reliability in various combat scenarios. The ongoing conflict has catalyzed Ukraine's exploration of innovative technologies to counter persistent drone threats from Russia. The introduction of laser technology aligns with a broader trend observed globally, as many militaries, including the US, UK, China, and Israel, are investing in laser weaponry as a cost-effective means to neutralize aerial threats. The exploration of these technologies reflects a shift towards more modern and efficient forms of warfare. In summary, while Ukraine's deployment of mobile laser firepower units signifies a strategic response to the challenges posed by Russian Shahed drones, the effectiveness of such systems will largely depend on ongoing testing and integration efforts. The military's optimism about the potential of these technologies must be tempered with an understanding of their operational limitations and the complexities associated with their deployment in the field. The report on Ukraine's deployment of advanced laser mobile firepower units to counter the threat of Russian Shahed drones contains several critical aspects that may be overlooked by the general public yet are significant in understanding the broader implications of this military strategy. 1. Emphasis on domestic technological innovation. One of the most noteworthy elements is Ukraine's commitment to developing its own defense technologies, as articulated by Colonel Vadym Sukharevskyi and President Volodymyr Zelenskyy. This focus on domestic innovation not only showcases Ukraine's resilience but also serves as a strategic pivot in the conflict. By investing in homegrown solutions like the Trizub laser weapon, Ukraine aims to reduce reliance on foreign military aid and technology. Significance. This is significant because it reflects a broader trend in military strategy where nations prioritize self-sufficiency in defense capabilities. This capability could enhance Ukraine's operational independence and potentially inspire other nations to develop their own technologies, reducing the global arms dependence cycle. 2. Integration of laser technology into existing frameworks. The report notes that while laser systems are being integrated into military operations, there are inherent challenges regarding their integration with existing air defense systems. Experts highlight that laser technology, despite its potential, comes with logistical hurdles, particularly in terms of energy requirements and operational adaptability in various environmental conditions. Significance. The emphasis on integration challenges is crucial. It underscores that while innovative technologies can transform military capabilities, their practical application requires careful planning and adaptation to existing systems. This insight can inform military planners and policymakers about the complexities of modern warfare, where technology must be seamlessly woven into established strategies. 3. Operational limitations of laser weapons. Military analysts caution against over-reliance on laser systems, pointing out that they may not be as effective against fast-moving aerial threats. The requirement for sustained targeting and the potential impact of environmental factors like weather could limit their operational effectiveness. Significance. Understanding these limitations is vital for realistic military assessments. Overestimating the capabilities of laser technology could lead to strategic miscalculations in combat scenarios. This highlights the need for a balanced approach to military technology, where innovations are viewed as part of a larger arsenal rather than standalone solutions. 4. Global context of laser weapon development. The report situates Ukraine's advancements within a global trend where countries like the US, UK, China, and Israel are investing in laser weaponry. This context is critical for understanding the competitive nature of military technology development. Significance: recognizing this global landscape can inform geopolitical strategies and alliances. As countries advance their laser capabilities, there may be shifts in military power dynamics, prompting nations to reassess their defense strategies and partnerships. This could lead to new forms of warfare and defense collaborations that reshape international relations. 5. Potential cost-effectiveness of laser systems. The narrative suggests that laser weapons may offer a low-cost per-shot alternative for engaging lower-value aerial threats, thus preserving more expensive missile systems for high-stakes targets. Significance: this cost-effectiveness aspect is particularly relevant for nations with constrained defense budgets. It raises important questions about the future of military spending and the allocation of resources in defense strategies. Countries may need to consider how to balance traditional and innovative military capabilities to maximize operational efficiency. 6. Psychological and strategic morale boost. The announcement of deploying laser weapons could serve as a significant morale booster for Ukrainian forces and the populace. The perception of advancing technology may enhance confidence in the military's capability to defend against aerial threats. Significance: morale plays a crucial role in military effectiveness. A boost in confidence can lead to improved performance in combat and a stronger public support base for ongoing military efforts. This psychological aspect can be as important as technological advancements in determining the outcome of conflicts. 7. Importance of continuous testing and feedback. The report indicates ongoing testing of the laser systems to ensure their effectiveness. This iterative approach to technology development is crucial in refining military capabilities. Significance: continuous testing emphasizes the importance of adaptability and responsiveness in military operations. It reflects a modern understanding that technology must evolve based on real-world performance and battlefield feedback, ensuring that military capabilities remain relevant and effective. Conclusion. In conclusion, while the deployment of laser mobile firepower units by Ukraine is a significant development in its military strategy against drone threats, the deeper implications of this move extend beyond mere technological advancement. From the emphasis on domestic innovation and the challenges of integration to the global context of military technology development and the psychological impact on morale, these overlooked aspects provide a more comprehensive understanding of the strategic landscape in which Ukraine operates. Recognizing these elements can inform future military planning and international relations as nations navigate the complexities of modern warfare. 1. Strategic enhancement of aerial defense. The deployment of advanced laser weapons, specifically the Trizub laser system, marks a significant shift in Ukraine's aerial defense strategy against the persistent threat of Russian Shahed drones. Colonel Vadym Sukharevsky's emphasis on the importance of unmanned capabilities highlights the military's recognition of the evolving nature of warfare, where traditional defensive measures are increasingly inadequate against modern aerial threats. This strategic enhancement aims to not only neutralize drones effectively but also to ensure the defense of critical infrastructure, showcasing an adaptive military response to real-time threats. 2. Technological innovation in counter-drone operations. Ukraine's focus on innovative technological solutions is pivotal in the context of the ongoing conflict. The testing and anticipated deployment of laser systems indicate a proactive approach to countering drone warfare, indicative of a broader global trend where militaries are exploring directed energy weapons as a cost-effective means of neutralizing aerial threats. This commitment to harnessing cutting-edge technology reflects Ukraine's determination to maintain operational superiority and adapt to the challenges posed by Iranian-supplied drones, thus playing a crucial role in its defense strategy. 3. Challenges and limitations of laser systems. Despite the optimism surrounding laser weaponry, significant challenges and operational limitations must be addressed. Military analysts have pointed out that laser systems might face difficulties in engaging fast-moving targets and are subject to environmental factors that could impede effectiveness. The need for substantial energy sources and proper integration within existing air defense frameworks further complicates their deployment. Understanding these limitations is essential for realistic expectations regarding the operational capabilities of laser weapons in a dynamic battlefield environment. 4. Global trends in military technology. The development and deployment of laser weapons by Ukraine align with global military trends where nations such as the US, UK, China, and Israel are investing in similar technologies. This collective move towards directed energy systems signifies a paradigm shift in military strategy focusing on low-cost per-shot solutions for countering aerial threats. Analyzing these trends helps frame Ukraine's actions within a larger context of modernization in military capabilities, emphasizing the importance of innovation in contemporary warfare and the need for nations to adapt swiftly to emerging threats. 1. The development of the U.S. Airborne Laser ABL program. The U.S. military initiated the Airborne Laser program in the 1990s to develop a high-energy laser weapon mounted on a modified Boeing 747. The goal was to intercept and destroy ballistic missiles during their boost phase. Although the program faced numerous technical challenges, it represented an early attempt to integrate laser technology into military operations. The ABL was ultimately cancelled in 2011 due to cost overruns and limited effectiveness against advanced missile threats. 2. Israel's Iron Beam system. In response to the growing threat of rockets and drones from groups like Hamas and Hezbollah, Israel developed the Iron Beam system, a ground-based laser weapon designed to intercept short-range threats. Testing began in the early 2020s, with the system intended to complement existing missile defense layers like Iron Dome. Iron Beam employs directed energy technology to intercept incoming projectiles at lower costs per shot, similar to Ukraine's current strategy against drones while facing challenges such as weather conditions and integration with other defense systems. 3. The Soviet Union's use of laser weapons in the 1980s. During the Cold War, the Soviet Union developed several laser weapon systems, including the Peresvet, which was reportedly designed to blind enemy satellites and missiles. The military utilized these systems in strategic operations to gain a technological edge. While the effectiveness of these systems in combat was never fully realized, their development marked a significant moment in military technology, showcasing the interest in directed energy weapons long before modern advancements. Future outlook: Ukraine's deployment of advanced laser mobile firepower units. As Ukraine prepares to deploy advanced laser mobile firepower units to counter the threats posed by Russian Shahed drones, the future landscape of warfare, particularly in the context of aerial combat and drone defense, is likely to undergo significant transformations. Here are several predictions regarding the implications of this strategic development. 1. Enhanced military capabilities. The deployment of laser weapon systems will likely enhance Ukraine's military capabilities, allowing for more effective and cost-efficient responses to drone threats. As these systems have demonstrated the ability to penetrate metal and engage targets at altitudes over 2 kilometers, Ukraine may experience a reduction in reliance on traditional missile and artillery systems, leading to lower operational costs and increased sustainability in prolonged conflicts. 2. Evolution of drone warfare. The introduction of advanced laser systems will force a re-evaluation of drone warfare strategies. As laser weapons can neutralize aerial threats with precision, adversaries may need to adapt by developing drones that are more resilient to laser attacks or employing tactics that minimize their exposure to such defenses. This could lead to an evolution in both offensive and defensive drone technologies. 3. global arms race in laser technology. Ukraine's advancements in laser weaponry could catalyze a global arms race in directed energy weapons. Countries observing Ukraine's progress may accelerate their own research and development efforts in laser technologies. This trend was already apparent with militaries worldwide, including those of the US, UK, China, and Israel, investing in similar technologies. The race could stimulate innovation but also raise concerns about the proliferation of advanced military technologies. 4. Integration challenges. Despite the promising capabilities of laser weapons, challenges regarding their integration into existing military frameworks will persist. The operational limitations of laser systems, such as energy requirements, performance under adverse weather conditions, and the need for precise targeting, will necessitate ongoing research and development. Ukraine will need to overcome these challenges to maximize the effectiveness of its laser units in real combat scenarios. 5. Shift in tactical approaches. The deployment of mobile laser firepower units may lead to a shift in tactical approaches for drone defense. Military planners will likely explore new formations and methods of operation that leverage the unique advantages of laser systems. These might include the establishment of dedicated laser defense units that can rapidly deploy to intercept aerial threats, thereby altering the dynamics of battlefield engagements. 6. International collaboration and support. As Ukraine continues to innovate in counter-drone technologies, it may attract increased international collaboration and support. Other nations facing similar drone threats may seek partnerships with Ukraine to share knowledge and technology. This could lead to a broader coalition of countries focusing on developing joint counter-drone strategies and technologies, enhancing collective security against common adversaries. 7. Potential for asymmetric warfare. The successful deployment of laser technology could empower smaller nations or non-state actors in asymmetric warfare contexts. If laser systems prove effective against drones, they may become accessible to a wider array of military forces, leveling the playing field against larger, more established militaries. This democratization of advanced military technology could lead to shifts in global power dynamics. 8. Legal and ethical considerations. The deployment of laser weapons will raise legal and ethical questions regarding their use in warfare. As these technologies evolve, international laws governing armed conflict may need to adapt to address the implications of directed energy weapons. Debates surrounding the legality of using lasers in combat, particularly concerning civilian safety and collateral damage, will likely gain prominence in military and diplomatic circles. 9. Impact on defense spending and budget allocations. The focus on advanced laser technologies may influence defense spending and budget allocations within Ukraine and other countries. As nations prioritize investment in innovative military capabilities, traditional defense expenditures may face reconsideration. This shift could lead to a reallocation of resources towards research, development, and procurement of cutting-edge technologies, impacting defense industries globally. 10. Long-term strategic implications. In the long term, Ukraine's deployment of laser mobile firepower units could reshape the strategic landscape of Eastern Europe and beyond. As Ukraine continues to innovate and enhance its military capabilities, it may emerge as a leader in advanced military technologies, influencing defense policies and military strategies among its neighbors and allies. The success of Ukraine's laser initiatives could establish a precedent for future conflicts, emphasizing the importance of technological superiority in modern warfare. Conclusion. In summary, Ukraine's initiative to deploy advanced laser mobile firepower units marks a pivotal moment in the evolution of military technology and drone warfare. While the immediate goal is to counter the threats posed by Russian Shahed drones, the broader implications of this strategic development will reverberate through military tactics, global arms dynamics, and international relations for years to come. The effectiveness of these systems in real-world applications, alongside ongoing challenges, will ultimately determine their role in future conflicts.